Okay, this is lesson 6.8, applying coordinate geometry. So we hope to, when we're finished, be able to name the coordinates of special figures by using their properties. So we're going to begin with this example as a precursor to our lesson that I saw on one of Joshua Moore's videos. Okay, so the directions say to classify the quadrilateral as precisely as possible. So you have point A is negative 3a and 3a. Point B is 3a, 3a. Point C, and then point D. So the first thing we're going to do is plot the points. So when we're plotting these points, notice that they all have A. Okay, so A is just a variable, and since they all have it, it's all going to do the same thing to each point that we're working with. So I'm just going to look at the coefficient, which is either 3 or negative 3. So for point A, we go left 3, up 3, and then plot. For point B, it's positive, so we go to the right 3, and then up 3, and then plot. For point C, we go to the right 3, and then it's negative 3a, so we go down 3, and then plot. And then D, we go to the left 3 because it's negative, and then down 3. So the first thing I'm going to want to do is see if I can figure out what the length is of segment AB. So if point A is negative 3 from the axis, this is going to be 3a. Point B is going to be 3a units from the axis. So the length of AB is going to be 6a. So we're going to do the same with these. So from B to the x-axis is 3 units, well actually 3a units. C to the x-axis is going to be 3a units. So that is going to be 6a as well. Notice that our answers are positive because distance is always positive. So we'll do D to C. That's going to give me 6a. And segment AD is going to give me, you guessed it, 6a. So if the lengths of all of my sides are 6a, what could we possibly have? We could have a rhombus, or if I have right angles, it could be a square. So this is just me thinking out loud. So now, let's see. We need to figure out these angles. I need to see what angle A, B, C, and D are. Now what's the slope of segment AB? So right here, what is the slope? So it looks like it's possibly going to be 0, right? So what's my formula for slope? My slope is my rise y sub 1 minus y sub 2 over my x's, x sub 1 minus x sub 2. So, three a minus 3a over negative 3a minus 3a. So that gives me 0 over negative 6a. What's 0 divided by anything? That's right. I have a slope of 0. Okay, so in order to know that this is a square, this angle, all the angles actually, need to be 90 degrees or perpendicular angles. How can we tell by the slope if an angle is a perpendicular angle? Do you remember? An angle is perpendicular. It will be the negative reciprocal. So we are hoping that BC that we're looking at over here will be positive 6a over 0. Let's see what we get. Okay, so for BC, we're going to do rise over run. So 3a minus a negative 3a, so that's going to be a positive, over 3a minus 3a, so that gives me 6a over 0. What is anything divided by 0? It is undefined. So that is a vertical line. And what kind of line do we have where the slope is 0? We have a horizontal line. So we have a horizontal line and a vertical line. That tells me that this angle is 90 degrees. So if we were to continue doing this, we would see that A and D also have 90 degrees. So this is a square. Okay, now on this one, I want you to bear with me. Because notice that all of our points are variables. Well, except for this 0. We've got a few zeros and lots of variables. So how can we make sense of that? So we want to name the points of M and N. Okay, and M and N are the midpoints of their respective sides. So for M, on this first one, M is going to be the sum of the x values. So that's going to be A plus C. And we're going to take the average of that. So we're going to divide by 2. That's the x value of point M. Now for the y value, we're going to do the same thing. B plus D divided by 2. Now let's do N. N is going to be C plus E divided by 2. D plus B divided by 2. Now I want you to notice that the y value for point M and point N are the same. So I could rewrite this one to B plus D, or I could rewrite this one to D plus B. So your y values are the same. So that tells you that this is a horizontal line. So now let's take a look at figure 2. Now notice that this one, the base of the triangle is on the x-axis, and this corner over here is at the origin. So now PQR, we have AB, CO, and OO, or 0, 0, I guess I should say. So let's take a look at point M. So M is 0 plus A divided by 2, and A, my x value, whoops, sorry, and 0 plus B divided by 2. I went on to where I wasn't ready to go, which simplifies down to A over 2 and B over 2. So those are the coordinates for point M. Now let's look and see the coordinates for point N. So this would be A plus C divided by 2, B plus 0 divided by 2, so we have A plus C divided by 2 and B over 2. Notice again that my N value, my Y value of M and N are the same. Now let me corral this. Oops. Let me move this over to give us some room for figure 3. Okay, so now notice that it's still on the x-axis, the base is on the x-axis, but y cuts through our shape. So for M, we have negative 2a plus 0 divided by 2, and 2b plus 0 divided by 2, which simplifies down to negative a b for point M. Let's see what we get for N. N is equal to 2c plus 0 divided by 2 and 2b plus 0 divided by 2. So that's going to leave me with C and B. So notice how this one looks really bad on figure A. It's not on the x-axis, it's just floating around in quadrant 1. B looks a little bit better for our 2 points. A over 2, B over 2, A plus C over 2, B over 2. Looks a little bit better. So while this figure doesn't look so good, it gives us the cleanest numbers for M and N. Okay, so this one wants to know what are the coordinates of the vertices of the figure. And this one for A, we have S, Q, R, E. SQ is equal to 2A. And a key piece of information is that the axes bisect each side. So if the whole way from S to Q is 2a, how long is it? How far is it from S to the y-axis? It's a units long. What about from Q to the y-axis? Well, it's a units long. So it's a square. So I know that QR is also equal to 2a. So how long is it from Q to the x-axis? It's a. What about from R to the x-axis? That's a units long. Have you noticed a pattern? So all of these are a units. And we know that because it's a square and because they tell us it bisects each side. What does bisect mean? It means breaks into two equal parts. So if I wanted to know what are the coordinates of S, what would you say? So it goes to the left. How many units? A units. So negative a. How many units up is point S? Positive a. Now Q is a units to the right. So that's going to be positive a. And a units up, that's going to be positive a also. Now R, we go over to the right, a units. Notice we're going in the positive direction. And then down a units. So R is the point, a, negative a. E is the point, a units over to the left, so that's going to be negative a, and down a units, so that's going to be negative a as well. So those are our coordinates. Now let's look at B. TRI is an isosceles triangle where TI is equal to 2a. The y-axis is a median. Okay, so from T to the origin, how far is that? Well, that's a units. From I to the origin, how far is that? Well, that's a units as well. So let's write down the coordinates for point T. So we go to the left. So it's going to be negative a. Do we leave the x-axis? Nope. So point T is going to be located at negative a and 0. Point I is going to be located from the y-axis. We go to the right, a unit, so that's going to be positive. Do we go up? Nope. So we're going to have 0 here. Now R is the one that may stump you, because they didn't give me a variable for this. That's okay. I can give it one myself. So I'm going to call this distance h. So from the origin to R is h units. So point R is on the y-axis, so do I go left or right any? No. So it's going to be 0 and H. Okay, so we're going to be using variable coordinates in this problem. So this diagram shows a general parallelogram with a vertex at the origin and one side along the x-axis. What are the coordinates of D? The point of intersection of the diagonals A, B, C, O. Okay, so we have a parallelogram. What do we know about the diagonals of parallelograms? They bisect each other. So I know that OD is congruent to DB, and I know that CD is congruent to AD. I do not know that the diagonals are congruent to each other. I just know that they bisect each other. So this is one of the times that it can save you some time if you will look at the numbers that you're going to be working with. So I could work with this. So I'm going to go ahead and write the origin points out here, 0, 0. So I could work with this, or I could also go over here and do these two, because I'm looking for the midpoint. So D is equal to, let's do this way first. Let's do CA. Two B plus 2A divided by 2. 2C plus 0 divided by 2. So this is equal to B plus A, because the 2's cancel out. And C. Now let's see what would happen if we did it the other way. So we're still finding point D. So this time we're going to use segment OB right here. So we have 2A plus 2B plus 0 divided by 2, and 2C plus 0 divided by 2. That 0 is not doing anything, so now we are left with A plus B and C. So we got the same thing no matter which way we did it. So this way was taking a left and this way was taking a right. So we went different ways, but we both got to the same destination.